So our research proposal looks at linking sleep quality to next day focus in adolescent classroom attention. For our abstract, sleep is essential for maintaining attention, yet many adolescents experience irregular or inadequate sleep. This study examines how sleep variability, particularly continuity and architecture, predicts ocular attention outcomes in LA high school students. Using EEG/PSG, we will assess sleep efficiency, wake after sleep onset, REM, and slow wave sleep, while eye tracking measures classroom attention. 100 students, 50 who are male and 50 who are female, will be randomly assigned to sufficient or restricted sleep conditions for 2 weeks. We hypothesize that sleep efficiency and slow wave sleep will more strongly predict attention than REM, with chronotype moderating effects. Findings will clarify how real-world sleep quality shapes adolescent focus, informing both sleep science and educational strategies.
For our research proposal, we decided to study how sleep affects the attentional abilities of high school students in a classroom setting. Previous literature stated that attention is critical for academic success, task completion, and social interactions, and this was found in a study done by Lin and Dinges. It was also found that sleep deprivation leads to major declines in attention, reaction time, and cognitive decline efficiency. This was found in a study done by Wust et al. Mechanisms of impact. Vigilant attention is disrupted by homeostatic and circadian dysregulation. This is stating that your ability to stay alert and keep your mind on a task is affected by your lack of sleep and inner circadian rhythm. Flexibility and top-down guidance refers to your ability to switch between tasks in a classroom setting and what your brain chooses to focus on or ignore distractions. Previous theories related to attention and sleep include attention network theory and dynamic attentional control. Gaps in research include the fact that most studies are done in lab settings with adults, not schools. There is a limited focus in research on real-world classroom attention. Few studies also consider cultural and contextual influences. The purpose of the study is to investigate how sleep quality and duration affect next-day attention in high school students. We also want to apply existing theories to classroom settings. A practical insight to our research is, can sleep interventions improve focus and learning outcomes?
Okay, now we comes to literature review, and here is Mo and Cui. And so first of all, we're going to talk about why study sleep and attention. High school, specifically grades 9 through 12, is the developmental window where biological and environmental pressures on sleep collide. And circadian phase delay intensify just as slow wave sleep, or what we call this SWS. It naturally starts to decline, increasing misalignment with persistently early school start times. And layer on heavier homework loads, screens, extracurricular, and commuting, and we get chronic restriction plus fragmentation too. And at the same time, academic stacks and sustained attention demands rise sharply. Autonomy over bedtime expands, so variability in sleep continuity increases, which is great for detecting associations here. Doing this in LA County adds ethnic, socioeconomic, and linguistic diversity that most prior adolescent sleep attention studies lack, making the findings more generalizable and directly relevant to ongoing start time policy discussion. And then it's the key construct and objective measures. Here we deliberately define sleep equality as two separable components. First is continuity, which is captured by sleep efficiency and wake after sleep onset. And architecture is the proportional makeup of REM and SWS. This let us test whether restorative deep sleep versus general continuity better predicts next day attention. We stage sleep with the reduced channel home polysomnography setup, necessary because RT-graph cannot distinguish SDVS from REM, and chronotype is modeled as a continuous score to capture circadian alignment without discarding variance through arbitrary grouping. And on the attention side, we use remote infrared PCCR eye tracking at the 112 Hz plus. Our primary metrics triangulate sustained focus, proportion of on-task gaze with task-relevant regions, blink rate, or variability as a marker of lapse, and fixation dispersion indicating spatial instability, and pupil diameter variability is exploratory, indexing arousal regulation under controlled lighting. Together, these metrics provide granular, objective endpoints rather than relying solely on subjective reports or like performance scores. And last but not least, here is the gaps framework and hypothesis explaining why our study is necessary. Here, it's like the pre-adolescent work really integrates both sleep continuity and architecture with high-frequency ocular attention metrics in a generally diverse high school sample, nor does it treat chronotype as a continuous moderator. And the theoretical frame combines the two-process model with the prefrontal vulnerability account. Adequate continuity permits sufficient SPS, supporting synaptic and metabolic recovery in prefrontal circuits, underpinning sustained visual focus. REM may contribute more to attentional flexibility, potentially reflected in dispersion rather than sustained locking onto the text. Circadian misalignment, common in evening type students forced into early schedules, may dampen or like kind of dilute these restorative links. Thus, we predict that sleep efficiency and SOS percentage will be the strongest positive predictors of on-task gaze and reduced blink rate, with SOS adding unique variance beyond efficiency. And REM effects are exploratory, expected to associate more with fixation dispersion. And finally, greater eveningness is expected to moderate or weaken the beneficial association of continuity and SOS with attention.
For this study, we are proposing a quantitative experimental research design to explore the effects of sleep duration on in-class focus among high school students. This approach allows us to control the independent variable, which is sleep duration, and to measure the dependent variable, which is student focus, in a systematic and objective way. The study will follow a between-subjects design and will be carried out over 2 weeks. A total of 100 high school students, 50 who are male and 50 who are female, will be recruited from various schools across the greater LA area. By drawing from a large and diverse population, the study gains stronger external validity, making the results more generalizable to the broader student population. Once recruited, students will be randomly assigned to either a control or experimental group. Random assignment is critical as it minimizes bias and ensures both groups are comparable at the start. Students in the control group will receive 8 hours of sleep per night, while those in the experimental group will be limited to 5 hours. This difference is significant enough to test our hypothesis, but not extreme enough to cause harm to participants, especially since the study is during school hours. To monitor sleep patterns, each participant's REM cycles will be tracked using EEG brainwave monitoring. During the school day, their eye movements will also be recorded through an eye tracker device, providing an objective measure of classroom focus. Data will be collected daily, and a thorough cleaning process will be conducted afterward. This consists of any student with irregular sleep patterns or pre-existing sleep disorders to be excluded, ensuring that our results reflect the true impact of the manipulated variable. Finally, because participants are under the age of 18, parental consent and confidentiality agreements will be required. These safeguards protect both the integrity of the study and the well-being of the students. By keeping the study at 2 weeks only, we balance the need for robust data with the responsibility to minimize disruption to student health and their academics. In short, this carefully structured methodology is designed to isolate the role of sleep in student focus and to provide meaningful, generalizable insights into how rest affects learning in the classroom.
In this study, there are several important limitations to acknowledge. First, because sleep quality is not randomly assigned, it is not possible to make definitive causal inferences, and residual confounding may remain despite statistical adjustment for factors such as stress, illness, school start time, ADHD symptoms, or menstrual cycle stage. Typical aspects also present limitations. Home sleep monitoring with portable EEG or PSG can be affected by sensor displacement, score variability, and the first night effect. Similarly, a classroom's attention measured through remote eye tracking is sensitive to calibration drift, head motion, eye ray reflection, and variable lighting. While blink rate and pupil size are collected, both can reflect multiple influences beyond attention itself, which limits interpretability. Environmental classrooms variability may alter gaze patterns independently of sleep, and ocular metrics in general may fail to capture internal states such as mind wandering. Another limitation lies in the sample. The study focuses on high school students in Los Angeles County, so findings may generalize other populations from other regions, religion, or school systems. And a volunteer bias may yield under representation of certain socioeconomic or educational subgroups. Chronotype is measured with questionnaires rather than psychological biomarkers, which introduce measurement noise. As this is an observational design, adequate reparent measures and sample size are required for causal validity, while missing data could weaken conclusions. Relativity and burden further limit the study. E.g., use may disrupt sleep, classroom observation may influence behavior, and participant fatigue could increase missing data. Finally, the study outcomes are restricted to immediate day after classroom attention measures rather than long-term academic performance. Turning to delimitations, this project is deliberately focused on adolescents in Los Angeles County, examining only naturalistic school night sleep at home in relation to classroom attention of the following day. Weekends, holidays, and naps are intentionally excluded. Sleep quality is defined as a continuity, with all sleep time considered control rather than quality. Attention is measured only through ocular metrics, specifically gaze proportions, blink rates, and fixation dispersion, while pupil diameter is treated as exploratory and included only under stable lighting. Chronotype is included as a continuous score for analysis, but not as a criterion for inclusion. The study relies on evening EEG or PSG for sleep staging, with validated reduced channel devices used for only if necessary. Attention assessment is limited to 120 Hz, remote infrared eye tracker within the classroom. No laboratory or neuroimaging measures are included beyond sleep EEG. Importantly, this is a naturalistic observational study with no experimental manipulation of sleep. The main analysis tests whether sleep efficacy and slow wave sleep percentage predict next day attention more strongly than REM sleep, with chronotype model as a moderator and adjustments for pre-specific covariates. Participation is limited to students able to comply with sleep and classroom monitoring, while conditions or medications that significantly alter sleep or attention may be grounds for exclusion or sensitive analysis. Inferences from this work are confirmed to a short-term classroom concentration in adolescents without drawing conclusions about long-term academic outcomes, clinical diagnosis, or other aspects of development.
Our dissemination plan for our proposal is to target audiences such as sleep science and education communities. For publications that are sleep-focused, there are American Psychologist, Journal of Sleep Research and Sleep Health. Education-focused research includes Trends in Neuroscience and Education, Journal of Experimental Psychology Applied. If our school allows it, we can also paste it to the lab website and university news page. There are also professional networks such as LinkedIn we can post our research. Conferences including Sleep Annual Meeting and Cognitive Neuroscience Society would be beneficial to present at. There are also other conferences such as Psychonomics and Association for Psychological Science. If our campus allows, we can also do local campus presentations. Practical takeaways for our research include actionable findings, sleep quality thresholds for next day attention, and ready-to-use slides and figures to support adoption and citation.
Adolescence is a time when sleep often becomes irregular, and that lack of consistency can directly impact how well students are able to focus in class. In this project, we're looking at not just at how long teenagers sleep, but at the quality of their sleep, specifically its continuity and its structure. To do this, we'll use objective tools like EEG and eye tracking, which gives us a more accurate picture than any past study that focused only on the total number of sleep hours. Our study will involve a diverse group of high school students in LA, which makes the findings more broadly applicable, and we're also considering individual differences like chronotype, which may influence how sleep and attention connect. If our hypotheses are right, we expect to show that high-quality sleep, particularly efficient sleep and slow-wave sleep, play a crucial role in sustaining attention the next day. Ultimately, the goal is to provide evidence that can guide practical changes for students, educators, and even policymakers. By bridging sleep science and education, we hope to highlight ways to improve classroom focus and support the overall well-being of adolescents. Here, we've listed our references, and that's the end of our presentation. Thank you.